Okay, so this right here, this reaction, the top one, number 1, that is going to be endothermic. It's endothermic because heat is going into the reaction, adding to the reactants, and it makes the products. Over here, this is exothermic. It's exothermic because heat is exiting with the products. Heat is coming out of this reaction. So you can think about it in terms of heat. Heat is entering right here. Heat is exiting over there. If it's entering into the reaction, then it's endothermic. If it's exiting, then it's exothermic. Let's do some examples. So one kind of example would be, I like to use these. They're not chemical examples, but they're physical examples. I like the ice because it kind of illustrates this really well. Let's imagine now that you've got ice and it melts. So it's in your hand. It's melting. It's a reaction. You're going from H2O. All it is it's a change of state. You're going from solid to liquid. And the question is, where is heat in this reaction? Is heat on this side or is heat on that side?
That side.
Left side or right side? Where is a heat?
Right side.
Heat's over here?
No, it's on the left side because it's.
What if you
Wait,
need to melt this thing?
It's taking in heat.
But it's hotter on the other side because it's melted, right?
Ah,
No, it's taking in heat, so it's melting. So
maybe
it's
this will
on
help
the
with
Which
an energy
reactants?
diagram. Hold on a second. Over here, we've got reaction progress. That's
When
going
you
this
start
way.
off with, like,
And then we got
this
energy
is
going
the
this way.
reactant and this is the product.
Okay, so here, these are the reactants. And over here, this is the products.
So what's the difference between the reactant and the product? Oh, it's what you start with?
Oh my god. It's like we're going back to the intro to chemistry. Reactants are the things you start with, yes. They combine to make the products. Okay? Alright. So let's start off with the reactants. Reactants are the red line right there. That's where they start off with the energy. And then, in order to get to this state right here, the liquid state, which is a higher energy state, you're right. There's more energy in it. It needs to be given energy. So it's a higher energy state. There's more energy going into it. So when it changes from here to here, you need to put in, you better believe, you got to put in some energy. You got to put in some heat. So in order for this reaction to happen, it needs heat. So I'm going to put heat right here, plus heat. So because heat's on the reactant side, it's going to be entering this reaction. So therefore, it's going to be endothermic. Okay? It's counterintuitive because you think, oh my god, you just got to get these terms straightened out in your head. Okay? Heat is entering it here, so it's making this into a liquid. All right. Now let's do a different kind of H2O example. And I'm going to let you guys think about this chart right here. We've done an example with this before, but now you can probably guess where it's going to go. But let's use H2O as a gas. So it's a gas, vapor, water vapor, and now it's going into liquid form. Okay? So we can think of it a couple ways. One of them is where are they in terms of their energy? Is gas higher energy than liquid? Yeah, it's higher. So here's the reactants right here. So the reactants are going to be higher than whatever the liquid is, which is the product. So that's going to be lower. So when it goes from higher to lower, it's going to give off some heat. So over here, heat's going up. There it goes. Bye-bye. So heat is now on this side. So because it's now a product, it's going to be exothermic, right? Okay, and you feel it, it's going to be hot. That is why, I don't know if people might have told you this in the past, but that's why steam from boiling water is more dangerous than putting your hand in the water, because it gives you more energy when it goes from a gas to a liquid. So if you put your hand above steam and you let it sit there for a bit, then all those little H2O gas molecules are going to start condensing onto your skin, and they're going to give you all of the heat that they have, so they can become liquid. So it's a very dangerous thing to have. Put your hand over the some steam. Okay? Now, if you leave your hand in hot water, then obviously you're going to burn yourself too. But it just the gas does give you a lot of heat when it condenses. Yeah. On a cool day, if you want to warm up, on a hot day, and you want to warm up your drink, to set it out, all of a sudden you see water start condensing on the outside of it, right? That water is in the air. It's just water vapor that's already in the air. And then it starts condensing onto the glass. It'll make the glass start heating up. So that's a way to heat up your water if you're outside and it's a warm day. Not just the temperature, but just the water molecules giving off heat. Anyway, that's endothermic, exothermic. Okay? I'll ask you questions about whether something is endothermic or exothermic. You can think of it another way. You can think, is this thing going to be cold if I touch it? If it's cold when I touch it, that means it's taking my heat. Okay? This, when you have H2O freezing and vaporizing, that kind of leaves you out in the dark. You don't really know what's happening there because you touch it and of course it's hot because it's gas and hot water is going to be hot too. But if you think of other kind of reactions, if you touch it and it's cold, then that means it's going to be taking your heat. And other reactions where I said it produces heat, then it's going to obviously be exothermic.
Like osmosis, right? Like take it like balances out whatever you give and take.
Yeah, it definitely does. Okay. All right. That's endo-exo. Just going to be questions just like in your book, so you don't need to worry too much about that. Any more questions about this? That's good. All right, we can get rid of the endo-exo. Now balancing the equations. I need some help with this. Can someone give me a question in their packet that's a difficult balancing equation question? Let's see it. They want to go over. Yeah. Just tell me, just give me like a blank. Say blank, then what?
Blank, parenthesis, NH, small 4, parenthesis,
Yeah.
small 3, P, O, small 4,
Oh my god, let me just see it.
number 9.
Oh, that's a tough one. Okay. Let's see, this one. This one's very tough.
Will you give us like something like this?
Like someone like this, probably not. But this is a hard enough one that this might actually be worse because it'll be more confusing than it'll be helpful. Let's try it though.
No, like never when I was.
This is actually kind of an exception. I don't know if I want to do this one. It's an exception because you think about these things in chunks. It's going to be really confusing if we start going individual element by individual element, which is the only way I have you guys solve it, right? So you're kind of choosing the challenge problem.
Do this one.
You should not do this one. As a review, probably not the best one to do.
But what about when we give back our packets? We won't know. Like, I don't know the answer.
Oh, you don't know the answer?
We just throw numbers as we did.
Oh, no. Don't just throw. I mean, I can go through it. I'll solve them as chunks, if that helps. But then we can do an easier one, I'll say. So this first one is going to be a more challenging one. This is not something that you'd see on the test. And it's going off the screen right now. So this one's going to be... where are we at? It's going to be a 4 right there. Make sure I get this right. NH4NO3. Okay, so this is added over there. Now, here you go. This question right here, I use this in the mostly in the honors class because they've learned about these things right here, these chunks of the atoms that always kind of travel together. These chunks of atoms, they have a special name called polyatomic ions, which is not important for you guys. You don't need to know that stuff, okay? It's just know that there are chunks of atoms, and that's how we're going to solve these. We're going to treat those chunks as if they're individual elements, okay? So instead of NH4, think of this as, I don't know, think of this as like H, okay? Just one single element. Think of it as like that big chunk, and then you've got 3 of them. So think of that as like an H3. Does that make sense? Mm-hmm. Because that NH4 doesn't split up. It's over there as well.
So that's also like H4.
So this over here, if you're going to continue this trend, if we
it's
say
like H1.
that would just be H. Okay, so we're going to treat them as just chunks that don't split up, because they don't split up in this reaction.
And then
Okay?
NO3.
That's why this one's so tough.
So it wouldn't be smart to like first like do like N3H12 and
We could split that up like that, and that is a way to solve it. Believe me, it is. But it's also a very long way to solve it, too. And I want to solve this quickly, so I'm going to treat them as chunks. So let's just do that. Let's pretend right here, NH4, let's treat that as its own element. NH4 does not break up. So we've got 3 NH4s over here. And we've got 1 right there. Right? So if we consider this entire chunk, and that entire chunk right over here, what do we need to do to this side over here?
take it off and then put 2 there.
No, 3. We want, because there's 3 of them. Okay, there's NH4 and there's 3 of them over here, so we want to make there's 3 over there. Right, so that's our first, those are now balanced. I'm treating them just like individual elements, okay? PO4, that's the second element. I'm going to make a different color with this one. PO4, it's a different chunk. Over here, oh my god, there's 4 of them over there. Ah, there's only 1 over here. So what do we got to do? Put a 4 over there. So now that is balanced, but oh, we got to go back to this because now this is unbalanced. What the heck? Whew. So now this is going to have, okay, so since now there's 4 times 3, there's going to be 12. This is why it gets confusing. 12 of these NH4s. You with me so far? Okay. Then over here, we just balanced that, so let's just take this off here. Let's make this now 12. So now this and that balance. So we're still good.
Oh, I got it.
Okay. Now, let's go over here. PbNO3,4. The Pb, we can treat as its own element. Because it is an element. So Pb right there, and then we got Pb3 right there. So we got to put a 3 right here. So now the Pb's are all good. What about the NO3 right over there?
That's fine.
The NO3 is okay? So there's an NO3. The NO3, there's 3 of this entire thing, so it's 3 times 4, so that's 12 of the NO3s. And over here, oh my god, they're all balanced. It's a miracle. So that's how you balance
Yeah,
out.
but what
So
about
it's
the
43
like,
by 12.
4s that are on the outside that we kind of like?
The 4 is on the outside right here.
Now you multiply it.
Yeah.
That one? So that means there's 4 of those NO3s in this molecule, but there are 3 molecules. So overall, there are 4 times 3, 12 NO3s.
So are you going to like this one that's hard for like an extra kind of problem, maybe?
Oh my god. No.
I figured it out.
I know this is your strong suit. But it's not for a lot of people.
I did that like 111 test grade.
And Mason's totally like, what's going on? Or you're like, I don't care about this. Let's do one. Let's do one that's.
One that's gonna be
Yeah, let's do one that's gonna be
Like
on the
number
test.
1.
Yeah.
Okay. Let's look at another one.
How about number 10?
Of course, you do that one. Yeah, let's do number 10. Number 10's fine. Okay. So number 10 is blank SeCl6 plus blank. Oh, I know why you want to do these because you just want to get them done so you can have your workbook done. Blank Cl2. You're very see-through. All right. Where do you want to start? Who wants to try this one? Does anybody want to try it?
No.
What's that?
No, I did number 10.
What needs to be balanced?
No, it's mostly that.
We should start with the
I already did number 10.
biggest one, right?
Where do you want to start? That's the question. Sam, let's start. Where do you want to go?
So I see that the SC is balanced.
So you're looking. Okay. So where are you looking? Are you looking here? Okay. So you're looking here. So the SCs, that's balanced. That's balanced. We're good over there. And Cl6. What about that?
That's not balanced.
It's not balanced. We got Cl6 over here, and we got Cl2 over there. So what do we got to do?
3.
You got to put a 3 in front of this so they're balanced out. So now it's all good. What about the O2?
It's balanced.
It's totally balanced.
So this
Both
is
sides.
the
This
level.
is pretty easy.
That was the easy one.
Oh my god.
See, I already did that one.
So did I.
Believe
It's
me, you
intense.
guys, when you're